All right, this is our third section from Chapter 2, Uses of Data. So before we move on, we've got a couple things that we're going to be looking at. But before we do that, I want to talk about tools we use to kind of get down and look at the data. And so first two sections, we talked about dealing with things at the bit level. Now we're going to be talking about things at the byte level, and we're going to be looking at them typically in hex. Not at the binary level. We'll pretty much just be looking at things at the hex level or even at the ASCII level. So to do that, we have tools that we call hex editors. And there are some tools that are hex viewers, which just let you look at the data, as opposed to a hex editor, which allows you to actually go in and totally screw up your machine. So that's what we're going to be dealing with. We're going to be going into what we call hosability mode, where you can hose up your machine pretty good using these tools, but we'll work on some safety tips for that. Okay. And there are a number of different hex editors out there. Some are free, some cost a lot of money. We're going to pretty much stick with the freebies here in class. And we're going to start off with one called HXD. And we'll have you work on that in class and some of your home exercises. Again, it's a free tool. So when you can open up a file or a drive, different things using this tool. We'll start out real easy here, showing an example of opening up a text file. And what you see here is first a column header called offset, and I'll talk about that here in just a second. We then have 16 columns. You'll see 00 through 0F. So there's our 16 columns. And then off to the right, you've got the actual ASCII character. So if, for example, in this case, if you were under column 00 and on the first row 4F, that corresponds with the capital O in the word outside over on the ASCII part. So if we were to move over one character to the lowercase u, that's going to correspond with that hex value of 75. And so those 16 characters in hex correspond with the 16 characters that we see on the ASCII side. Okay. To open up a file, obviously it's just file open, and you can look at the contents of that. Okay. So I mentioned the word offset. So we see that column header. What that means is an offset is a reference from the beginning of a particular area. In this case, we're talking about a file. So if I gave you an offset and I said go to offset hexadecimal 10, that's from the beginning of the file, starting counting at 00. Okay. So this is going to be a concept that you're going to be dealing with a lot. We're going to say go to offset whatever, 32, or might be 4236, whatever, either in the file, or it could be from the beginning of a hard drive, or from a sector, all different areas. That has to be specified to you because you're not going to know what we're talking about, but we'll say go to offset 63 from the beginning of the sector or from the beginning of the file, and that will be included in that. Okay. Now this offset value can either be represented in hex in HXD, or it can be represented in decimal. Typically we go to decimal because that's what we're used to, but there are some advantages to seeing it in hex as well. You'll see here listed here, so first offset is 0. The second row begins hexadecimal 10, which is 16. Okay. And then 20, which is 32, 30, which is 48, 40, 64, so forth. So once you kind of get in that mode, it's pretty easy to count that way. But again, most of us deal with decimal most of the time, so you can put that offset in decimal, and maybe make your life a little easier that way. Okay. To do that, we go under View, and then Offset Base, and then we select Decimal. Now, you want to be really crazy, you can go to octal. We're not even going to that. I've never seen anybody use octal before, but anyway, you can do hex or decimal if you want to do that. Okay. So again, we have the hexadecimal side and then we have the corresponding ASCII side. And so whenever you move the cursor, both sides will automatically adjust. Note that any changes of the hex will automatically change in the ASCII 2. This does not become permanent until you say save. So save will actually commit that to the disk. Okay. And again, I mentioned offset is from a designated point. And again, it can be from a file, sector, drive, record, attribute, and those words will mean more as we progress through the semester. But right now, either we'll talk about from the beginning of the file or from the beginning of a drive will tell you to go to a specific offset. And here, HXD will display that. So if you're requested to go to decimal offset 90 from the beginning of the file, you can see that. You can see that we're starting in row 80, and then we're going to count over 10 bytes. And you're going to have hexadecimal 47, which is the capital G, and Groucho, and then down at the bottom, it's going to tell you what the offset is. So you can always see that. And you can move your cursor back and forth between the hex side and the ASCII side by using the tab key. And then if you want to make a change, you can hit File Save. Now, one thing, if we look at data, so in this case, we've got the same file that we've saved in Unicode. And I'm trying to remember, I believe that we talked about Unicode the very first week when we talk about bits and bytes. So we understand that there are actually 2 bytes of information for every character. So if we start over on the ASCII side and you see the capital O in the word outside, you will see that there's a little period after that. Now that's just a designation for a space. If we look over on the hex side, again starting with 4F, so we're going to go 3 bytes in. 4F is our capital O, and then 00. And then 75 is our lowercase u, and then 00. And then 74 is our lowercase t, 00. So 00 is padding in the Unicode value. And again, we talked about Little Endian and Big Endian. This is Little Endian. So for a 2-byte value for capital O in Unicode we're going to read that from right to left. So that's actually 004F. Okay, so we've got 2 bytes representing. It's exactly the same if it was a single byte of just 4F by padding it with all zeros in front of it. But this is how it would look like in a hex editor if we've got ASCII data. Now, obviously because we've doubled the number of bytes for every character, we're going to double the size of the file as well. Okay. So that's just a little introduction to HXD. We're going to be playing around with that quite a bit for the next few weeks, but I just kind of wanted to provide that basic information for you.